Oh snap! Oh snap! Oh snap!
Elsa?
Okay. Lamborghini.
Saw, dude. So, groups are the vertical columns in the periodic table, and they hold elements, and these elements have similar properties to each other. So, there are 18 groups. Let's talk about the first one. These are your alkali metals. So, the alkali family is found in the first column of the periodic table, as I said, and they have one valence electron. So, they are very reactive because they will pretty much combine with anything to get to that magic 8 number that they want. So they're very reactive. They can be cut with a knife pretty easily, and they're very shiny and have the consistency of clay. So these alkali metals will react violently with water and air, and that's pretty crazy. So you'll have to watch a video of that. They put them in the water and they just kaboom. It's really cool. So, and also the alkali metals are never found as free elements in nature, and they're always bonded with another element, which is the reason why they're so reactive. So, that's alkali metals. Thanks for listening.
So earlier, Thomas talked about groups in the periodic table. Now I'm going to talk about their counterparts, periods. There's 7 of them throughout the periodic table. They're horizontal rows going across it. From left to right, it shows the increasing number of the element's atomic mass. Now, the second group of the periodic table are called alkaline earth metals. They're never found uncombined in nature, but they're still somewhat reactive. Not as reactive as the first group, but they still are. Now, they have 2 valence electrons. And you see, as they're in the second group, you'll start seeing a trend that each group, it goes up. The valence electron goes up by 1.
Saw, dude. I'm back again. So these are your transition metals, groups 3 through 12. So these are the metals that you're probably pretty familiar with, that you hear all the time: copper, tin, zinc, iron, nickel, gold, silver. So these are super good conductors. Like, I'm sure you've heard about houses having copper wiring. They're good conductors. They're the stuff. So compounds of transition metals are usually really brightly colored, which you could see, of course, copper and all those. It's a bright brown metal. So transition elements have 1 or 2 valence electrons, which they lose when they form bonds with other atoms. So that would explain groups 3 through 12. So the only other thing you really need to know about transition metals is that they have high melting and boiling points, which makes them good conductors, because they're not just going to melt when you have electricity going through them. So that's your transition metals. Thanks. Saw, dude. I'm back. So next we're going to talk about the boron family, which is group 13. It's named after boron. Go figure. Atoms in this family have 3 valence electrons, and this family includes a metalloid, boron. Go figure. And the rest are metals. So that's pretty much it. Also, this group does contain aluminum, which is not a metalloid, even though it's on that stair ladder that you see. It is not a metalloid, and it is one of the most abundant metals in Earth's crust. So carbon family is group 14. They have 4 valence electrons. You see in the pattern here? I am. So this family includes a nonmetal, which would be carbon, and metalloids and metals. So carbon, let's just talk about that for a second. It's very important, okay? This is considered the basis of life. So carbon is a big deal. It's in the air. It's everywhere, all right? Nitrogen family, group 15. The nitrogen family is named after the element that makes up 78% of our atmosphere. What's the element? Nitrogen. Go figure. This family includes nonmetals, metalloids, and metals. Atoms in the nitrogen family have 5 valence electrons, and they tend to share electrons when they bond, because they only need 3 more to get to that magic 8.
So group number 16 of the periodic table is the oxygen family. And this family contains oxygen, obviously, which is the most abundant element in the Earth's crust. It's extremely active and combines with like all the elements. So, I mean, it's in everything. And this group, the atoms have 6 valence electrons because it's group 6. There's the pattern again. and most elements in this family share electrons when they are forming compounds. Group number 17 of the periodic table is the halogen family, and these elements contain 7 valence electrons, and that is why they are the most reactive nonmetals. They are never found free in nature. And the halogen family atoms only need to gain 1 electron to feel their outermost energy level. So, and they react with the alkali metals to form salts.
The 18th group of the periodic table are noble gases. Noble gases have the perfect number, 8 of the 8 valence electrons, right? So this means they're very unreactive, right? They don't want to give away any electrons. They want to take on any electrons. And this is very important when it comes to the periodic table. Most noble gases are found in small amounts in the Earth's atmosphere. Now, the last family of the periodic table we're going to talk about is way down at the bottom, the rare earth elements. Now, they're called this because you rarely find them in nature. They're usually only created in the lab for a few seconds. Most of them are synthetic, man-made, as I said, and they're very unstable.